A current carrying rectangular loop is in a magnetic field region as shown in the picture, and we'd like to calculate the net torque about the hinge on the left hand side. First, let's determine the magnetic force acting on each segment. The formula for magnetic force acting on a straight current carrying wire is I times L cross B, I being the current passing through that segment or the wire. L is the vector with magnitude equal to the length of the wire and direction pointing in the direction of the current. And B is the magnetic field vector. Now, because we have a cross product, any segment that is parallel or anti-parallel to the magnetic field vector is going to have zero force acting on it. And segments BC and AD are such segments. They're either parallel or anti-parallel to the magnetic field, so the cross product is equal to zero because the sign of the angle between the two vectors is equal to zero. One is sine 0, the other is sine of 180 degrees. So no force on segments BC or AD. Next, let's focus on segment AB. Now the vector L points in the direction of the current, so it's pointing up, so it's vertically up. And when we do L cross B for this segment, we get the force, magnetic force, pointing into the page. So if you align your right hand along the direction of vector L, which is from point A to B, vertically up, and then curl your fingers in the direction of vector B, pointing to the right, your thumb is pointing into the page, and that's the direction of the magnetic force acting on this segment. So there is a force acting on segment AB, however, that's where the hinge is. So this force is applied at the hinge, consequently it cannot create any torque. So torque created by force AB is equal to 0. And finally, let's focus on segment CD. Now the direction of vector L for this segment is vertically down. Align your right hand vertically down and then curl your fingers in the direction of the magnetic field, which is to the right. Your thumb is pointing out of the page towards you, and that is the direction of the magnetic force acting on this segment. Only one force is able to create torque about the hinge, so the net torque is equal to the torque created by that force, which is force acting on segment CD. And the torque that this force applies on the hinge is equal to the magnitude of the force times 2L, which is the perpendicular distance between the force and the hinge. And remember, the force is pointing out of the page. So let's also determine the magnitude of this force following the force formula here. The magnetic force acting on a straight current carrying wire, it's equal to the current capital I times L, the length of the segment CD, that's just capital L, times the magnetic field magnitude capital B, times sine of the angle between vectors L and B, which is 90 degrees, and sine 90 is 1. So in the next line, let's simplify this expression. Here's our final answer. Net torque about the hinge is equal to 2 times IL squared times B.